This video is going to talk about how to find your inverse trigonometric functions using the unit circle. First, let's talk about notation. We've been using things like this: sine theta equals x, cosine theta equals x. I guess we've been using y's instead of x's here, but sine theta, cosine theta, tangent theta. Either way, that means your sine fraction at angle theta is x. If we want to use the inverse, we'll flip these two values, and you can either use the notation arc sine, arc cosine, and arc tangent, or you can use sine, cosine, and tangent with this little -1. Kind of looks like an exponent, but that's the inverse notation. And what that means is this notation is asking you for the angle that gives us a sine fraction of x is theta. So I'm giving you the sine fraction, you have to give me the angle. Normally I give you the angle and you give me the sine fraction. That's how inverse functions work. They just switch your x and y values, or in this case, your x and theta values. All right, in my notes, I have a little bit better description of where this comes from on your unit circle, but for now, I'm just gonna cut straight to the chase. When we look at the unit circle, for inverse cosine, we only look at the first and second quadrants. So I can ignore this x value, this cosine fraction, everywhere on the bottom of my unit circle. So inverse cosine or arc cosine is only in the first and second quadrants. All right, for arc sine or inverse sine, it's only in the first and fourth quadrants. So we can ignore my y values, that's your sine fraction, in the second quadrant and in the third quadrant. So we're not actually using the third quadrant at all. We are also going to be looking at tangent values, and if you remember, the tangent value is found by taking your sine numerator and dividing it by your cosine numerator. And we just have to worry about numerators when we're on the unit circle because they have the same denominator, so they cancel each other out. First, let me say that arctangent or inverse tangent is only going to be in the first and fourth quadrants, just like sine. So I can ignore this left-hand side of the unit circle. And then I'm going to go on and write out my tangent values, and that is created by saying sine divided by cosine numerator. So tangent is square root 3 here, 1 over square root 3, but you need to rationalize, 0 over 1, -1 over square root 3, but rationalize, negative square root 2 over square root 2, and negative square root 3 over 1. Also, don't forget your axes. At -1 over 0, we can't divide by 0, so tangent is undefined here, and we also have to deal with there. Okay, so one last thing before we have our unit circle set up the way we want it to be when we're looking at inverses is to talk about these angles down here in the fourth quadrant. It's not quite so easy as just picking out your angle straightforward and saying, oh, the sine fraction, where's the sine fraction? -1/2? Oh, it's at 11 pi over 6. Of course, it's not that easy. You need to use negative angles down here in the fourth quadrant. They're negative coterminal angles, so you can just subtract 360 or subtract 2 pi from all of them, or flip all of these angles down over your x-axis, reflect them all over. This would be -30 degrees and negative pi 6s. This middle one would be -45 and negative pi 4ths. I know you can't really see. This would be -60 or negative pi 3rds, and then straight down would be -90 or negative pi over 2. Let's clean that up. So this is what we're looking at. I have tried to get rid of anything that was irrelevant to inverses when I made this right here. So I've only pulled out the cosine fractions and the sine fractions where they should be. I've only listed the tangent fractions here in blue where they should be, and I've already changed these to negative angles down here. This is what we're going to be using over and over and over again today. Whenever you see the inverse notation, that arc sine, arc cosine, arc tangent, or the little -1 like an exponent, this is the unit circle you need to think through in your mind. So this is the unit circle, it's just we've edited it some. All right, let's do a bunch of examples, and I'm going to keep this here because we are going to just keep using it over and over and over again. All right, first, let's determine inverse sine of square root 3 over 2. All right, they're giving me the sine fraction, positive square root 3 over 2, and I need to give them the angle. Inverse sine is only over here on the right-hand side, and it's the y coordinate, so square root 3 over 2 happens here. You can give your angle in either degrees or radians. Since I didn't specify, you should probably start thinking in terms of radians, because if you plan to take calculus, that is what you will be thinking and using. But if you want to write 60 degrees too, that is fine with me as long as you are in the right spot. I don't care if you use degrees or radians, unless I specify. If I say use degrees, then you need to use degrees. All right, example 2. Inverse cosine of negative square root 3 over 2. Inverse cosine is only across the top. Cosine is my x coordinate point, so I need to look through where is negative square root 3 over 2. Oh, that happens here at this angle. And I am going to use radians, but you could also say 150 degrees. Keep going. Inverse sine of negative square root 2 over 2. So inverse sine is only on the right-hand side. It's the y coordinate, so I'm looking for negative square root 2 over 2. That happens down here. We're in the fourth quadrant, so remember I can't just use that 7 pi over 4 or that 325. Is that the right degrees? It's straightforward from the unit circle. I have to use negative angles here, so I'm going to say negative pi fourths radians, or I can say negative 45 degrees. Make sure you don't forget the negative sign, because I almost totally forgot it when I was writing degrees just then. All right, I decided to use the arc notation just to get you used to it. That means the same thing as if I had done tangent to the negative 1. This is all just inverse tangent. That's not to the negative 1, because that's kind of an exponent. It's really confusing. I don't know why they use this notation, but you got this. Okay, arctan, inverse tan of square root 3. So inverse tan is only on the right-hand side. I'm looking at all this outside extra information that I gave it. I'm looking for positive square root 3. That occurs here at this angle measurement, pi thirds, radians, or 60 degrees. When you write this on your classwork or on your test, you only have to give me one answer, the radians or the degrees. I'm just doing both, so that way you have them both. But you only have to give me this radian answer, or you only have to give me this degree answer, not both. Okay, inverse tan of negative 1. So on the right-hand side, I'm looking for negative 1. That occurs here at, remember, these are negative angles in the fourth quadrant, so negative pi fourth radians, or at negative 45 degrees. Perfect. I am giving you the fraction from the outside of the unit circle. You give me the angle from the inside of the unit circle. Anytime you see this inverse notation or this arc, which is also an inverse notation. All right, well, what's happening for these last couple examples? I have double things going on. This is called composition. When you compose your trig functions, you want to work from the inside out. So we are first going to figure out what is arc sine of square root 3 over 2. Okay, I'm giving you the square root 3 over 2 fraction. You give me the angle. This is sine, so I'm looking at the y coordinate on the right-hand side. So that is at pi thirds, or you could use 60 degrees. So I can replace all of this with just a pi thirds. And now, this is regular cosine. So I can use my straightforward normal unit circle, because regular cosine, not inverse cosine, can be anywhere. So regular cosine, what is the cosine fraction at pi thirds? We go to pi thirds. Cosine fraction is the x piece, so that is 1/2. And I'm done. Let's do a couple more examples of that. So work from the inside out. All right, so I'm giving you inverse cosine of negative square root 2 over 2. Inverse cosine is across the top, so look for negative square root 2 over 2 in the x piece. And that angle, or where that occurs, is at 3 pi over 4. So this equals sine of 3 pi over 4. Okay, this is regular sine. So regular sine occurs everywhere, not just on the right-hand side of my unit circle. So it's okay that this is 3 pi over 4 in the second quadrant. So go to 3 pi over 4 and tell me what is the sine fraction at 3 pi over 4. Sine is your y piece, so that is square root 2 over 2. And we're done. All right, let's keep on going. You don't have to have your inverse piece on the inside. You can just have a normal sine function on the inside, or cosine or tangent function. So sine of 30 degrees. This is a sine, so we're looking at our normal unit circle. Go to 30 degrees, and the sine fraction is 1/2. All right, now this is inverse sine. Arc sine is inverse sine. That means I'm looking for where is the sine fraction positive 1/2 on the right side of my unit circle. So look at your y coordinate pieces. That occurs at pi over 6 radians, or you could say 30 degrees. I guess I should say degrees since I started in degrees. And look at that. A lot of times that happens if you have an inverse and the regular function, so inverse sine and sine, inverse cosine and cosine, inverse tangent and tangent. A lot of times these two answers are the same. What was inside your, nested inside your parentheses and your final answer. But as you'll see in the next example, that's not always true. All right, sine of 2 pi over 3. This is regular sine, so I can go on my whole entire unit circle. So even though I'm in the second quadrant here, it's regular sine, that is okay. So what is the sine fraction at 2 pi over 3? Oh, it's square root 3 over 2. But I have this inverse sine now on the outside that I have to deal with. So inverse sine can only be on the right-hand side of my unit circle. So on the right-hand side of my unit circle, where's the sine fraction, the y coordinate piece, equal to positive square root 3 over 2? That occurs here at pi thirds, or 60 degrees. I'm going to use radians because that is what I started with. So if your angle that you're given is in the first or fourth quadrant, your answer is going to be that same exact angle. If the angle that you're given is in the second or fourth quadrant, because sine can be anywhere, but inverse cosine can't, these answers aren't going to match up. Just little heads up. All right, let's do one last example. Let's do one with tangent because I haven't done that yet, but you will do these on your classwork and homework. Work from the inside out. So this is regular cosine. Look on your whole unit circle. Where is regular cosine equal to 0? I said that wrong. It's not equal to 0. This is 0 degrees or 0 radians. What is regular cosine fraction at 0 degrees or 0 radians? So at 0, regular cosine fraction is 1. So all of this is 1. But now I have to take the arctan of that. So arctan of 1. So on the right-hand side of my unit circle, where is my tangent fraction equal to positive 1? So tangent fraction is positive 1 up here at pi over 4 or 45 degrees. I guess I didn't specify if that was in radians or degrees, so your answer can be pi over 4 or 45. But it's the same idea.